Alright, this video is going to go over some surface modeling techniques in Rhino. So I'll just jump right into it. You've probably used the extrude command before, but just to go over that again, it will basically take a base curve or surface, usually planar and usually closed, and stretch it in one direction. So if I extrude this square, I can decide which way I want it to go and how far I want it to go. You'll notice you have some options. If you wanted to make something that extended 2 units in both sides and had open ends, these are kind of the options you'd want. And then for the distance, you can punch in 10. So this will go 10 units in each direction. You can double check that, and looks good, 10 centimeters. So I wanted to mention you can really use any base curve for this, so it doesn't matter if it's a kind of unusual curve. Whoops. So this will still work. Maybe I only want one direction and I want it to be solid and I want to get rid of that base curve after I make the shape. So there you go. And then one other thing I wanted to mention is that you don't always have to extrude in the direction perpendicular to the curve. So, for example, if I wanted to make kind of a slanted cylinder, I could do that pretty easily. Just click the direction option, and then usually I make a couple points to determine the direction. So I'll kind of have it going diagonally to the left, and that looks pretty good. So the next command you might want to use is loft, which basically is built out of cross-sectional curves of whatever shape you're trying to make. And a few things to remember with that are the curves don't all have to be the same type of curve. So here I'll do one with 2 ovals and a rectangle, and that should still work out perfectly fine. For the seam point, you just want to make sure that they basically align on the curves, and looks like the computer was pretty close on this. Make sure those white arrows are all pointing in the same direction. This is a pretty simple one, so usually the defaults will be perfectly fine, but sometimes if you're doing a really complicated loft with like 30 irregular curves, you might have to be more careful with that. But this looks good. If you want to cap it, you can just make it closed loft actually doesn't cap it. It would make it wrap all the way around and connect with itself again. So I'll show you that in the next example. But for the style, you can kind of control exactly how it interpolates the surfaces between those cross-section curves. So normally you'll probably stick to normal, loose, or tight. Loose and tight just refer to how closely the surface hugs those curves. Straight sections just means they're all going to be planar facets as much as possible. So I'll try normal for this one, and that looks pretty good. Also, if you wanted to close it, you could just cap it. The closed loft option is more for if you're creating a shape that intersects into itself. So say I wanted to make a ring with a kind of square cross section. I could use all of these, loft them. You can see all of those are on the same corner, so that looks good. All the white arrows point the same way, those little guys. There we go. So I'll loft that. And I want to make this a closed loft. That just means it will connect into itself. So we'll get that like fully closed shape. Something you probably haven't used too much before that might be really handy if you're building something like kind of like any like bracing underneath a structure is the pipe command. That basically just takes any curve or series of curves and turns it into a pipe or a cylinder. So you can control the radius. I'll have this one. I'll just leave this one at 1 centimeter radius, and that looks pretty good. Likewise, if I wanted to, I could have the radius change throughout. So if I wanted it to start at a radius of 1, I could have it end at a radius of 3, and that'll give you kind of a more like conical shape. One trick with this is if you're working with multiple piped curves, at some point you'll want to Boolean union them. So if I made 2D on this right now, it wouldn't really represent the intersections of all the pipes because they're actually two different surfaces. So basically you want to go through and select each section one by one and Boolean union them. So now the computer recognizes this as one poly surface. So I could go through with all the others, do the same thing. I'm just hitting enter because that redoes the last command you used. And now we have one nice uniform surface. So a similar command is called ribbon. It basically does the same thing, but instead of creating a pipe, it creates a sort of ribbon, kind of flatworm type thing. So you can pick the side to offset, you can pick how far you want to offset, and you can control how it handles corners. So maybe I want the ribbon to be 2 centimeters wide. I'll take the defaults for the other things. There we go. And that gives you a nice flat path. So a really handy one to know if you're working with things with radial symmetry is the revolve command. Basically that takes something, spins it along a predefined axis, and creates a solid wherever that curve passes through space. So I have here a 7-pointed star, and I want to spin that along a vertical axis and spin it all the way around to create a solid object. So I'd select the curve, revolve command. For the axis, I can just draw it based on the shape. Sometimes you might have to put points in. And in this case, I'm going to rotate it all the way around to make a full circle. So that gave me this really interesting, nice kind of like fountain shape, or spinning top, something like that. Sweep 1 and 2 are some of the most useful commands in Rhino, in my opinion, for building surfaces. Those basically let you take a cross-sectional curve and slide it along a rail, leaving a surface behind in all the space that the curve passes through. So for example, I could do something, this is basically going to mimic the ribbon command for this first one because I'm using a straight cross-sectional curve. So if I go through that, sweep 1, the rail is basically the path curve you want to use, so the thing you're moving the other curve along, so I'll use this one. And then the cross-section curves, that's just going to be this straight line that's moving along it. And if I do that, I get this nice kind of irregularly curved surface. You have plenty of options with that. You can explore those on your own. Most of them are pretty self-explanatory. I also want to add, though, you don't have to use a straight cross-section curve. So here I could use this little arc. Sweep 1, select the rail, select the arc, and if I do that, I'll get this really interesting kind of tunnel-like roof shape. And last, you can actually use closed curves to do that. So you could even use a circle, pretty much the same procedure. And you get this really big pipe shape. Sweep 2 is effectively the same thing, except it uses 2 rails and will stretch the cross-section curve as necessary to make it stick to those 2 rails. So in the first example, when you're using a straight cross-section curve, you'll select both rails and then the cross-section curve, and you can see that's stretching the cross-section to make it fit between both of those rails. So you can see the other 2 cross-section curves. This really gives you a lot of control over the surface you end up with. So in this case, I think the output will be a pipe with a variable radius. Whoops. Yeah, so a lot you can do with the sweep commands as well.